Hi, I'm Yuji Kano, a researcher of Fuji Xerox. So let me begin my presentation. Identifying implicit quotes for unsupervised extractive summarization of conversations. My research is about extractive summarization. Extractive summarization is a method to extract important sentences from the source text. The data I worked on are online conversations. Online conversations include chat, email, and social media. And because massive data are being transmitted through online conversations, we need to seek for a way to summarize these data. Many methods of unsupervised extractive summarization have been proposed, but most of these methods is based on one premise. The premise is that important topics are frequently referred to in a document. However, this is not always true. Some important topics are referred to only a few times. So for more accurate summarization, we need to focus on a different aspect of text. So we focus on quotes. When we reply, we sometimes use quotes to highlight part of text that we refer to. An example is shown here. Quotes generally start with this symbol. We can say that the part of a text replies frequently referred to is an important part. Therefore, we aim to predict quoted part and use it as a summary. If we can predict quoted parts, we can extract important sentences regardless of how many times the topic is referred to. This is previous research that assigned weights on words that appear in quotes and improved a centroid-based summarization model. However, most replies don't include these explicit quotes, so it is difficult to use quotes as supervision, especially when training neural models. So instead of these explicit quotes, we focus on implicit quotes. So what is implicit quotes? Some replies include quotes as shown on the right, but most replies do not include quotes as shown on the left. However, even if we don't explicitly quote, replies always refer to some parts of a text. We call this implicit quotes. For example, this reply does not have a quote, but when we look into the context, we know it refers to this green sentence in the text, in the post. So our aim is to predict implicit quotes and use them as summaries, so that we can predict quoted parts without using explicit quotes as supervision. To this end, we propose a model, implicit quote extractor. The input of the model during the training is a post and a reply candidate. The training task of this model is to distinguish whether a reply candidate is a true reply or not. Reply candidates can be a true reply or a randomly sampled reply. We first split a post into sentences, and the encoder computes the sentence features. We don't use all sentences for prediction. The extractor extracts a few sentences from the post to use for prediction. And because we can only use the limited number of sentence features for prediction, the extractor has to extract sentences that reply frequently referred to. We use attention and Gumbel softmax to decide which sentences to extract. We compute attention weights from sentence vector of the post and the hidden state of the extractor's LSTM. Because we use Gumbel softmax, the attention weights become nearly one hot vector. Weight 1 is assigned to one sentence, and the other weights become nearly 0. The sentence with attention weight 1 is used for prediction of the relation between the post and the reply candidate. And because we go through this process L times, we can use L sentences for prediction. And the number of L can be defined depending on how many sentences we need for a summary. So this is how our model IQE extracts sentences. Note that the model requires reply features only during the evaluation. This is because summaries should not rely on replies. Important sentences should be determined solely from the source text, which is a post in this context. This is why I wrote most likely B here. Implicit quotes themselves depends on reply. But because summarization should not require replies, IQE extracts sentences that can most likely be implicit quotes. So during the evaluation, the model can extract important sentences only from the post and does not use reply features. For training data, we have two datasets. One is avocado mail collection. We have approximately 56,000 correct pairs of posts and replies, and the same number on wrong pairs. The wrong pairs are posts and randomly assigned replies as explained in the last slide. The other dataset is Reddit Tifu, the social media dataset. We have approximately 183,000 correct and wrong pairs. And this dataset was provided by Kim, but it does not include replies. So we collected replies using Pro, which is a Python library. For evaluation data, we have three datasets. Two of them are email datasets, and one is social media dataset. The email datasets are a dataset of corporate mails and private mails. The detail of the datasets is described in the table here. We have two training datasets and three evaluation datasets. So there's an inconsistency between the number of training datasets and the evaluation datasets. The model trained with avocado mail collection is used for the evaluation of two mail datasets. The model trained with Reddit training dataset is used to evaluate the Reddit evaluation dataset. We extract three sentences as a summary and evaluate good scores of first 20, 40, and 60 words. So here's the result. IQE is our proposed model, and the others are baseline models. On email datasets, our model outperformed baseline models in most metrics, especially on EPS data. And here is the results on the social media dataset. Our model, IQE, outperformed most baseline models, but not text rank. The reason why IQE did not perform well on the social media dataset is not actually clear, but it is conceivable that because Reddit users are not forced to reply, they're more likely to refer to unimportant words. And that is the difference between the email datasets, because when we reply to emails, we feel we have to reply to important parts of emails. We further discuss two hypotheses. Our model, IQE, is based on two hypotheses. First, we assumed our model can extract quotes, but because our model does not use quotes at supervision, it is not clear if our model can extract quotes. So we verified if IQE is more likely to extract quotes. Second, although there is previous research that used quotes for summarization, but that research used quotes as an auxiliary features. So it is not clear if quotes themselves can be used for summarization. So we verify whether extracting quotes leads to good summarization. In order to support our hypothesis, we conduct two experiments. So does our model extract quotes? To verify this, we checked if the extracted sentences coincide with actual quotes. We collected the data. For this verification, we need actual quotes. We collected the data from Reddit Tifu dataset. We corrected replies that have quotes. We use this symbol to identify quotes. And for total, we have approximately 2,000 replies that have quotes. We regard quote extraction as an information retrieval task and use mean reciprocal rank to evaluate this. Mean reciprocal rank is reverse number of the length. And summarization models can rank sentences in terms of importance. So we compute the reverse number of the length of quotes. And this indicates how well the model can extract quotes. The result shows that our model can extract quotes better than text rank, rect length, and random. Next, we verify the second hypothesis. Does quote extraction improve the performance of summarization? To verify this, we separate data that IQE succeeded in extracting quotes and otherwise. The former we call IQE quote, and the latter we call IQE non-quote. The result shows the performance is better when our model succeeds in quote extraction. This result supports that quote extraction leads to good summarization. We further discuss the difference between our model and the conventional method. As I described as a problem of the related works, most conventional methods are based on a premise that important topics frequently appear in a document. For example, text rank computes page length of each sentence and extracts the sentence with the highest page rank as a summary. If the maximum page length in a document is high, that means many sentences refer to the same topic. And if the maximum page length is low, that means sentences are basically referring to different topics. So the figure shows the correlation between Rouge and the maximum page length. If the maximum page length is low, the performance of text length becomes worse. Our model IQE achieves better results than text length when the maximum page length is low. This supports that our model IQE can extract important sentences, even if the topic is referred to a few times. We show a demonstrative example for this. The sentences extracted by text rank are shown green, and the sentences extracted by IQE are shown orange. The grand summary refers to promotion, baby, and roto stuff. But an IQE succeeded in extracting these sentences, but text rank did not. This is because these topics appeared only once in a source document. So the conclusion, we verified that the possibility of being quoted is useful for summarization and demonstrated that it reflects an aspect of important sentences that conventional methods do not. Second, we propose an unsupervised extractive neural summarization model, implicit quote extractor, and demonstrated that the model outperformed or achieved results competitive to baseline models on 2 meta datasets and a Reddit dataset. Third, using the Reddit dataset, we verified that quote extraction leads to a high performance of summarization. Thank you.